friends, as part of this video we will see high performance optimization techniques. As we all know, during the development of our project, taking care of the performance is equally important. So let's see each of the technique one by one. The first technique is choosing the execution engine. By default, we all know Hive under the net is using MapReduce only. But Hive query execution process can be increased by changing the execution engine. It means we can change the execution engine. Instead of MapReduce, we can use the Tej engine. So to use the Tej engine, we need to set a property, that is Hive execution is equal to Tej. Tej execution engine gives you 2 to 4 times high performance based on the cluster configuration. So if I compare my Tej execution engine with the MapReduce execution engine, so Tej execution engine is 2 to 4 times higher than MapReduce. Next is partitioning the table. So partitioning is nothing but distribution of your data. So Hive partition is an effective method to improve the query performance on a very large table. So friends, if you have a very huge data set of table, then you can store that data into the table and you can partition that table. By partitioning the table, we are scanning only the subset of the table, not the entire table. So that is the benefit we will get from the partition. So partition should always be applicable for low cardinality attributes. So it means country or the state. So cardinality means the occurrence of my values, column values. If that is low, then we should go for the partitioning. Next is bucketing. So bucketing is again a one more method to distribute my data across the cluster. Bucketing improve the join performance if bucket key and join keys are common. It reduces my IO scan during the join process. So friends, if my table is bucketed and I am applying a join operation on the same key on which I have bucketed my table, then this gonna be really high optimization, because it will reduce my IO operation, which ultimately reduce my seek time and the network traffic. So to use the bucketing, we have to set a property that is called set Hive enforce bucketing equal to true. So bucketing should always be used when you have a high cardinality of the data. It means employ ID like column, where your occurrence of your values is quite low. They are not repeating again and again. Next is de-normalizing your data. So friends, if your data is normalized, so it means to get your final set of result, you have to do lot of join operation. Okay, and we all know joins are expensive and difficult process to perform, and it is one of the common reason for the performance issue. So we should always try to reduce the join operation, and whenever I go for any join operation or any of the execution I go, before that I make sure I denormalize my data as much as I can do. Next is compression on my mapper side and my reducer side. So compression techniques significantly reduce the intermittent data volume. It means I am reducing my data size of the actual data. Reducing the data size internally reduce my data transfer between the mapper and the reducer phase over the network. So it means if my data is less, so I am shuffling less data across the network. It means less seek time, less IO operation. So ultimately this will improve my performance. So compression I can apply on my mapper side itself as well as on my reducer side itself also. There are certain set of compression technique we have. Those are like bzip, codec, snappy. So based on your requirement, you can choose any of your compression technique. So to set your compression properties, you have to set some properties like for the mapper set, for the mapper compression, you have to set map reduce map output compression equal to true, and when you want to go for the compression output format, then you say map reduce dot out dot file out format compression equal to true. Next is map side join. So friends, this is one of the most important. We use the performance technique in our Hive. So whenever we have a situation where I have one small data set and one a large data set, in that case we always should go for the map side join. So map side join is really efficient if one of the table is small enough to fit into the memory. In map join, we actually execute the join operation on mapper side itself and getting our final output. We are not running our reducer phase at all. That's why with the help of map side join, we are getting our join output with the help of mapper. But the condition is one data set or the one table should be small enough to fit into the memory. There is a syntactical hint which we use for the map side join, that is called /* plus we say map join and give our table. Hive support a parameter called Hive auto convert join equal to true. It means whenever there is a requirement of map side join, my Hive system will try to allow or apply the map join on my dataset automatically. So my system is smart enough itself. Next is input file selection. Yes, so selecting a correct input file is also a very important part when we go for the high performance. So input file format plays a critical role in our high performance. So and Hive comes with a columnar file format like ORC, Parquet, RC, etc. But if you talk about the studies, so ORC file format works well, or the best I would say, when we are working with the Hive, because internal properties of ORC file format contain some Bloom filter and bitmap indexes. Next is parallel execution. So friends, suppose in Hive if you are working with a really complex query, okay, so that complex query internally will be broken down into many map reduce jobs, okay, and those map reduce jobs will run into the sequence. This is the default nature of my execution. But there are certain map reduce job whose stages are not interdependent to each other, and those stages can be run into the parallel. So instead of running them in sequentials, we can get the benefit of the parallel execution. Okay, so to set this parallel execution property, we have to call a property called set Hive execution parallel equal to true. Next is vectorization. So friends, we all know when we work with the Hive, we are dealing with the rows one by one, but vectorization allows the Hive to process a batch of rows together instead of processing them one row at a time. So instead of running one row at a time, I am processing my complete set of row, a bunch of row at a time. So this will increase my performance quite well. To set the Hive vectorization property, we have to call a property called set Hive vectorize execution enable equal to true. So thank you. So these all are various performance technique that we can apply in our program or while working on our Hive queries. So friends, thank you for listening, and let me know if you have further more queries or question. You can comment, share and subscribe. Thank you.